Your mouth is on fire, your eyes water. Somewhere around the fourth bite of that wing, sweat starts rolling down your back, and every rational part of your brain says stop. You don't stop. You reach for a fifth. Someone at the table is filming. Someone else is laughing. And you keep going anyway, chasing a sensation that, by every biological definition, your own body has just labeled an emergency. Most people assume this is about flavor, about heat tolerance, about being tough enough to handle it. But the real answer is far stranger. Your brain isn't enjoying the pepper. Your brain is being tricked into believing your mouth is actually burning, and it's throwing a full chemical emergency response to survive a fire that was never real. This isn't a small, isolated habit either. Somewhere close to a quarter of the world's population eats chili peppers on a daily basis. From the street food stalls of Bangkok to the salsa bottles lined up in Mexican kitchens to the fiery hot pot broths simmering across Sichuan, an enormous share of humanity has voluntarily built pain into its daily meals, not as punishment, as pleasure. So what is actually happening inside your body every time you choose to do this to yourself? Start with the pepper itself. Chili peppers contain a compound called capsaicin. Sitting in a vial in a lab, capsaicin has no smell, no color, no true heat of its own. It only becomes dangerous once it touches living tissue. Here's the trick behind it. Your body has a receptor called TRPV1, sitting on the nerve endings across your mouth, throat, and skin. Think of TRPV1 as a thermometer switch. Normally, it only flips on when something crosses a real temperature line, somewhere around 109 degrees Fahrenheit, the point where tissue genuinely starts to burn. Capsaicin ignores that threshold completely. It binds directly onto TRPV1 and flips the switch anyway, at room temperature, with zero heat actually present. Your nerves fire the exact same distress signal they would send if your tongue were pressed against a hot stove. Your brain cannot tell the difference between a real burn and a chemical impersonation of one. Isn't that strange? A molecule with no temperature of its own, convincing your entire nervous system that you're being burned alive. The scientist who mapped out exactly how this hijacking works was David Julius. He spent years tracing the precise mechanism by which capsaicin locks onto TRPV1, work so foundational to how we understand pain and heat detection that it earned him a share of the 2021 Nobel Prize in Physiology or Medicine. His research didn't just explain why a pepper burns. It rewrote how scientists understood the entire system your body uses to detect danger, from spicy food to sunburn to frostbite. One receptor, one switch, and an entire category of human sensation traced back to it. It's also why capsaicin cream shows up in pharmacies as a pain reliever. Flood that same receptor long enough, and it eventually goes numb, unable to fire the alarm at all. That intensity gets measured too. The scale you've probably heard of, the Scoville scale, comes from a chemist named Wilbur Scoville, who devised a way to rank how much a pepper's heat had to be diluted in sugar water before human tasters could no longer detect any burn at all. A bell pepper sits at 0. A jalapeno lands somewhere in the low thousands. The world's hottest peppers, bred deliberately for competitive eating and viral videos, now climb past 2 million. Every single number on that scale is really just a measurement of how hard your TRPV1 receptors are being lied to. Not everyone starts from the same place, either. Taste researcher Linda Bartoshuk spent years studying why the exact same dish can feel wildly different from one person to the next. She found that a portion of the population, often called super tasters, carry a noticeably higher density of taste buds across the tongue, which makes them register bitterness, sweetness, and the burn of capsaicin far more intensely than the people sitting next to them. A dish that feels comfortably warm to one guest can feel genuinely overwhelming to a super taster 3 seats down at the same table. Genetics doesn't decide whether you'll ever learn to love spice. It only decides how loudly the alarm rings before you get the chance to. So, your body genuinely believes it's under attack. What happens next is where things get interesting. Your nervous system responds to that false alarm exactly the way it would respond to a real injury. It releases endorphins, your body's natural painkillers, chemically related to morphine. It also releases dopamine, the same neurotransmitter tied to reward, anticipation, and craving. The sting spikes first. Then a flood of natural opioids rolls in behind it, softening the pain into something closer to a glow. Your brain registers a rush, not a warning. It feels like danger with the safety rail still bolted on. Why would a body wire itself backwards like this, rewarding something that mimics injury? Psychologist Paul Rosen spent decades chasing that exact question. He noticed something odd about human behavior. People don't just tolerate painful or unpleasant sensations. They actively seek them out, on one condition. The body has to know, somewhere underneath the panic, that it is actually safe. Rosen coined a term for this pattern: benign masochism, the enjoyment of a sensation your body reads as dangerous while your mind quietly knows there's no real threat. Roller coasters work this way. So does jumping into ice water. So does watching a horror movie in a dark room with the doors locked. So does biting into a pepper hot enough to make your eyes water. All of them trip the same ancient alarm bells, and all of them pay out a reward once your brain confirms that you survived. The fear is real. The danger isn't. That gap between the two, Rosen argued, is exactly where the thrill lives. Rosen didn't stop at theory. In 1980, alongside researcher Deborah Schiller, he traveled to a rural village in Mexico to study how children actually develop a taste for chili. And what they found surprised nearly everyone who read it. Babies hate capsaicin. Every single one of them, without exception, spits it out and cries the first time it touches their tongue. Nobody is born loving spice. Yet by the time those same children reached adolescence, growing up in a culture where chili appeared at nearly every meal, most of them sought it out on purpose, ranking hot salsas among their favorite foods. The preference wasn't inherited. It was built, bite by bite, meal by meal, through repeated exposure paired with family approval and the simple visible fact that everyone around the table was eating it and surviving just fine. Nobody hands an infant a habanero and lets biology sort it out. The taste for danger, it turns out, is taught. Notice, too, that the rush doesn't only arrive with the bite itself. It starts before the fork ever reaches your mouth. Ordering the hottest option on the menu, scrolling toward a bottle marked with a skull and crossbones, watching a friend's face right before they take the dare. All of it fires dopamine in anticipation, the same neurochemical priming that makes the slow climb up a roller coaster's first hill feel almost as thrilling as the drop that follows. Your brain doesn't wait for the pain to start rewarding you. It starts the moment it recognizes the ritual, betting on the relief that has always come before. That anticipation is a large part of why spicy food became a social event in the first place, a shared countdown to a manufactured emergency that everyone at the table has quietly agreed to survive together. History backs this up on a much larger scale. Chili peppers are native to the Americas, and for most of human history, nobody outside that hemisphere had ever tasted one. That changed almost overnight after 1492, when European ships began carrying chili seeds back across the Atlantic as part of what's now called the Columbian Exchange. Within a couple of centuries, a plant that had never existed outside Central and South America had rooted itself into the defining cuisines of India, Thailand, Korea, Hungary, and Sichuan province, regions that had spent thousands of years developing food cultures with absolutely no chili in them at all. That kind of rapid, near-universal adoption doesn't happen with a flavor most people find genuinely unpleasant. It happens when a sensation offers something deeper than taste, something worth learning to love. There's a reason it was worth learning in the first place, and it may have nothing to do with pleasure at all. One theory reaches back before refrigeration existed anywhere on Earth. Researchers Jennifer Billing and Paul Sherman combed through thousands of traditional recipes collected from cultures across the globe, and they found a pattern too consistent to be coincidence. The hotter and more humid a region's climate, the more likely its traditional cuisine leaned on spices, chili included, and the more of them a single recipe tended to use. Heat and humidity happen to be exactly the conditions bacteria need to thrive in meat left sitting out. Capsaicin, along with several other common spices, carries genuine antimicrobial properties, strong enough to measurably slow bacterial growth in food. In other words, the burn on your tongue may not have started as pleasure at all. It may have started as a survival tool, wearing the disguise of flavor, quietly protecting people in hot climates from the food poisoning that came with living somewhere refrigeration could never reach. Which means the sensation lighting up your mouth tonight has almost nothing to do with the reason it exists in the first place. Capsaicin didn't evolve to entertain you. From the plant's perspective, it evolved as a weapon. Chili peppers produce capsaicin, specifically to punish mammals for eating them, since mammal teeth grind up seeds and destroy them before they can ever grow into new plants. Birds, on the other hand, lack the TRPV1 receptor entirely. They cannot taste capsaicin at all. They eat the fruit whole, pass the seeds through unharmed, and scatter them across the landscape, doing exactly what the plant needs done. The burning sensation in your mouth right now is a defense mechanism aimed squarely at creatures like you that somehow backfired into becoming one of the most popular flavors on the planet. Isn't it strange to think you're paying money to be punished by a plant that never wanted you anywhere near it? What started as chemical warfare between a plant and the animals trying to eat it became, over thousands of years, a survival trick adopted by the humans who kept eating it anyway. Then it became a taught pleasure, passed down at family tables, meal after meal, the way Rosen's Mexican village demonstrated so clearly. Then, somewhere in the last few decades, it became something else entirely: entertainment. Look at what's happened to chili culture recently. Hot wing challenges with names built to sound like dares, ghost pepper eating contests streamed live for an audience, bottles of sauce marketed specifically because they're almost too dangerous to finish, ranked on Scoville numbers most people can't even picture. None of that is about nutrition anymore. None of it is about keeping bacteria out of unrefrigerated meat. It's benign masochism, packaged, filmed, and sold. The exact mechanism Rosen identified decades ago, now performed for a camera instead of a village dinner table. The format spreads because it's built to be watched. A face that starts confident and ends up flushed, sweating, and gasping for milk makes for a better 15 seconds of video than almost anything else in a kitchen. Restaurants have built entire menus around a single unbearable dish near the bottom of the page, daring customers to sign a waiver before they order it. Sauce companies print skulls, flames, and warning labels on their bottles the way horror movies print blood on a poster, because the packaging itself is part of the thrill before a single drop touches food. None of this needed the antimicrobial logic that first justified spice in a hot climate centuries ago. The survival reason quietly disappeared. The chemical reward it left behind didn't. Every time someone films themselves crying, sweating, and reaching for a glass of milk after a single bite of the world's hottest pepper, they are chasing the same chemical loop their ancestors stumbled into completely by accident. Pain, spiking fast through a receptor built to detect real fire. Relief, flooding in right behind it through endorphins and dopamine. Reward, registering in the brain as a rush instead of a warning. It is the identical loop that makes people pay for roller coasters, horror films, and ice baths. Your nervous system doesn't actually know the difference between manufactured danger and real danger. It only knows how to respond once the danger is over. And that response, again and again, turns out to feel remarkably good. There's a reason some people chase this feeling far more than others, too. Sensitivity to capsaicin isn't fixed. It shifts with repeated exposure, the same way a muscle adapts to repeated strain. Eat chili regularly enough, and the TRPV1 receptors in your mouth become slightly less reactive over time, requiring more capsaicin to trigger the same burn. That's not toughness. That's habituation. The nervous system quietly recalibrating its own alarm threshold in response to a signal it has learned again and again not to fear. Someone who grew up eating chili at every meal isn't biologically different from someone who never touches it. They've simply run the experiment Rosen ran in that Mexican village thousands of times over, one dinner at a time, until the fire started to feel like home instead of an emergency. Think about what that really means the next time a bottle of hot sauce shows up on the table and someone dares you to try it. You're not being offered a flavor. You're being offered a manufactured emergency, small enough to survive, real enough to feel. Your ancestors stumbled into that trade by accident, somewhere between a plant defending its seeds and a culture defending its dinner from bacteria. You inherited the taste for it anyway, learned one meal at a time, the same way every chili lover before you did, and reinforced a little further every time the burn faded and the relief arrived right on schedule. None of it required you to be brave. It only required your nervous system to notice, over and over, that the fire always went out and that something warm and rewarding always followed it. So the next time your mouth is on fire and sweat rolls down your back and every rational part of your brain screams at you to stop and you reach for a fifth bite anyway, you'll know exactly what's happening underneath it. Your body was never really burning. Your brain simply loved how it felt to survive the fire it invented in the first place.